Shelly Cowley is the Technical Director for the Asphalt Emulsions Group at Paragon Technical Services. She previously was Director of Plant Technical Operations for more than 12 years. We've got sampling and testing by Shelly Cowley.
Good afternoon, guys. My name is Shelly, and I'm here today to share everything I know about emulsion sampling and testing that will fit into 20 minutes or less. Sampling asphalt emulsions. Why do we need to talk about sampling? Seems pretty straightforward, right? You grab a container, you go get some emulsion, bada bing, bada boom, emulsion is sampled. Well, this picture shows some actual examples of people who probably felt that same way. These are some of the containers that we see in the lab from time to time, and that's why it's important that we do talk about the proper way to sample emulsion. The purpose of sampling is really to obtain samples that truly show the nature and condition of the material that's being put down on the road. And test results are dependent upon proper sampling. If you go out and you take a bad sample, you're going to get bad results, and it's not going to truly be a reflection of what the material was that you received or applied to the road. So the first thing I want to talk about when you go out to pull a sample is PPE. That's proper personal protective equipment. You always want to make sure that you are wearing the proper equipment to take a sample safely. And those items are usually things like gloves, safety glasses, a face shield, and then long sleeves. Safety is always my first concern. Now, with just 20 minutes to discuss both sampling and emulsion testing, I'm going to cover the highlights, but for more detailed information, two great sources of information on sampling procedures are AASHTO R66, which is sampling of asphalt materials, and also ASTM D140, which is the standard practice for sampling asphalt materials. Both of these provide additional information on proper ways to sample asphalt and emulsions at production facilities, storage facilities, and the point of delivery. Most agencies and companies have sampling policies and procedures. And these procedures a lot of times will contain information on the proper sampling location, where they want the samples taken, how often samples need to be taken, the type of containers these samples should be taken in, and also PPE required. So when you're taking samples, make sure that you are meeting and understand the requirements of the applicable agency or company that you're pulling them for. Andrew just spent some time talking about the production facility and making the emulsions. So where are some typical places that you would pull a sample at that production facility? He showed pictures of storage tanks. Most storage tanks will have a sample valve on the tank itself that makes it very easy to get a good sample. Some production facilities may have a circulating line where you're able to circulate the material in that tank through a line and pull a sample off that line of the material flowing. And then also the emulsion mill itself. When the quality control that Andrew was talking about was being discussed, you actually have a sample valve usually right behind that emulsion mill where you can pull a sample of the emulsion on the way to the storage tank, and that allows you to do some of the quality control testing that he referenced. Now, when you're in the field, sample valves are still one of the best places to take your proper sample. So this is a picture of a tanker, and on the back here is a sample valve. And that goes for the same for a distributor. So sometimes these sample valves may be clogged, or you're unable to get sample to flow from them. And when that happens, what do you do if there's no sample valve or if it is clogged? A lot of times people may take a propane torch and heat that sample valve up to get that material flowing, but that always doesn't work either. There's also adapters that you can buy that you can attach where the pumping hose connects to the truck. And these adapters, this is an example of a screw-on adapter and a quick connect adapter that allows you to collect a sample still from that sample valve. Taking samples from the spray bar is not really recommended on the distributor. It does happen sometimes. The reason that's not recommended is because the emulsion has already been sprayed through a nozzle, and this can impact the liquid properties of the emulsion. Samples from the spray bar can also become contaminated from whatever was used to clean the spray bar. So just be aware that if you do sample from the spray bar, take that sample after approximately 1/3 of the load has been sprayed, and ensure there's no pressure on or in that spray bar from the pump before you pull that sample. When you do pull the sample, whether you're taking it from a valve or a spray bar, you want to make sure that a minimum of 1 gallon of material has ran through that sample valve and wasted before you begin collecting your sample. And that's to ensure that you have no contamination in that sample from whatever's left in the valve last. And then all emulsion samples should be collected in new wide mouth jars or bottles made of plastic or wide mouth plastic lined cans with lined screw caps. So this is a picture of just an example of some containers we do like to see used for sampling emulsions. You have just a typical gallon jug container. The reason the wide mouth is preferred is because when that gets into the lab, it's just a lot easier to take that lid off and actually stir the emulsion itself and make sure that it's completely homogeneous. It's a little bit harder to get a small opening stirred up well. Emulsion samples cannot and should not, well, they can, but they should not be taken in containers that have been previously used or in metal containers. The metal itself can interact with certain types of emulsions and cause some stability of the emulsion just in the container itself. These are some examples of containers that do get used in the field and that we do see in the lab. Again, all of these are there's just a source of contamination. You can contaminate your emulsion before it ever gets to the lab to test. One thing we do see, obviously, people are staying really hydrated out in the field because we see a lot of samples come in Gatorade bottles. So hydration's good, Gatorade bottles, not so good. When filling up the containers, they should be filled completely to eliminate possible crusting or skinning of the emulsion that can show up as sieve when it gets to the lab, excessive shaking from having a lot of empty space, or condensation in the container. When filling the containers, you want to avoid filling them too quickly because you may entrain air in that sample. Also, samples should not really be exposed to direct sunlight or allowed to freeze. So if you pull that sample, don't throw it in the back of your truck and drive around with it for a week before you think to send it to the lab. That's not going to be the best sample for testing when it gets here. And also, samples should not be submerged or wiped down with solvent. Again, the solvent that's left on the outside of that bottle can possibly contaminate the emulsion itself when we're pouring it up. And a lot of times these containers get put in water baths or ovens, and those can contaminate the water bath as well. Just use a clean, dry cloth to wipe off the container as best as possible if needed. Once you have your sample and it's filled up and you're ready to send it in, we should make sure that the sample is labeled with, at minimum, the following information. And that would be your product name, the sample date, sample time, sample location, and the sampler's name. We often ask that you put that label on the side of the container, and the reason for that is if you have a lot of samples in a lab and people are taking lids off and pouring up, testing with the emulsion, it's very easy for lids to get switched. And so if you do sample the lid, label the lid, just ensure that you label the side just as well. And any additional information, the more information on a sample, the better. So additional information like the project number or tanker number or anything else is always useful. So once you have your sample labeled and it's ready to be sent into the lab, you want to package it and ship it to the lab the same day that the emulsion sample is taken, if possible. That's ideal. On the picture that I showed earlier of the gallon jug, you might have noticed the black electrical tape wrapped around the lid. That's a really good practice to make sure the lid is sealed and taped on well. These are examples of just packages we've received just this year. You can see that UPS and FedEx is taking great care and gently and delicately delivering your samples to the lab to be tested. The cardboard box was actually taped up very well. It was a very nice box, but the lid on the container inside the box itself had come loose in shipping, and all the emulsion leaked out inside the box. Sample was here. We were not able to test the emulsion. The white cardboard box, actually, in that big box, there was only one container of emulsion, and it was a great container. It was taped up and labeled really well, but because nothing else was in that box, that entire box got ripped open, and we were actually delivered the box, another piece of the box, and a container. And then the bottom one is actually a 5-gallon bucket of emulsion that was put inside a plastic bag, which is also a really great idea, and then put inside a box. Unfortunately, the lid came off, cracked open on the 5-gallon bucket. A large majority of the emulsion spilled into the plastic trash bag, so it was contained. But again, we weren't able to really test the emulsion because most of it was inside a garbage bag. Just think what you would need to, how you would need to pack it if it was going to be dropped, ran over, or kicked before delivery, and go to that level of extreme so it can arrive safely. So that's really all that I have on emulsion sampling, and now we're going to talk a little bit about asphalt emulsion testing. For ease of discussion, I tried to separate the testing into two basic categories. One is characterization, and the other is performance. So characterization is what I mean by that is what type of emulsion do you have? You've heard people talk about cationic, rapid set. Those are the characters of the emulsion itself. So with this testing, we're looking to confirm, is it slow, medium, rapid, or quick setting? And is it cationic or anionic? What type of emulsion is it? And then the second category is performance. How will this emulsion apply out in the field? How quickly will the emulsion break? And how will this emulsion mix with aggregate? Some of the very common characterization tests are demulsibility. You may hear this called demulse. This test is used to identify rapid setting emulsions. Basically, you take a soap of the opposite charge of your emulsion. So if you're testing a cationic emulsion, you'll have an anionic soap, and you mix that together and look for a certain amount of that emulsion to break out. And by each of these tests, I've also listed the AASHTO or ASTM procedures, so you can go back and read more about these later if you want to know more about how the test is ran. A second characterization test is cement mix. This is used to identify slow set emulsions, and in this test, you basically mix cement with the emulsion, and it needs to be a slow enough emulsion with enough chemicals to mix and stay fluid when mixed with cement. And then the last one I have here is a particle charge test. And this test is measuring for a charge on the emulsion itself, and it's used to identify cationic emulsion. Application tests. Some of the common application tests, one of the most common ones that you'll hear mentioned is VIS, or that's short for Sabalt viscosity, and also another method of testing that is the paddle viscosity. Both of these tests are measuring the rate of flow of emulsion. How thick or thin is this emulsion, and is it appropriate for the given application? Is the emulsion thick enough so that when you apply it on the road for a chip seal, it's not going to run off and it's going to stay there for aggregate to be dropped on? Or is it fluid enough that you're going to be able to mix it with rocks before it's laid? Another application test is sieve, and Andrew mentioned that one. This is where we're measuring the uniformity of the emulsion by looking for oversized particles. So are there a lot of oversized particles that may clog your equipment or cause you problems when applying this emulsion? And then coating ability and water resistance. This determines if the emulsion can coat the aggregate and if the water resistance of that coated aggregate is where you want it to be. And then also the ability of the emulsion to withstand mixing. Those were the tests that are really done on the emulsion when it's still in its emulsified and liquid form. The rest of the tests we're going to discuss are done on the actual residue of the emulsion itself, so just the asphalt portion that you want to recover. So there's three basic ways that we recover residue from an asphalt emulsion. The first one is called residue by distillation. This is the quickest way to recover asphalt residue from an emulsion, and it's typically performed at either 177, 204, or 260 C, and it takes about an hour. And this residue recovery method will also provide you with an asphalt content percent, how much distillate content is in the emulsion, and also provides you then residue for performance testing. The second method is residue by evaporation. This is where the emulsion is poured into metal cans or containers and put into a 163 C degree oven for 3 hours. This provides you just asphalt content. You will not get a distillate percentage from this test. And it also provides quite a bit of residue for performance testing. And then one of the newer methods for recovering residue is called low temperature evaporation. And this recovery method is really trying to simulate what happens when you take an emulsion out and you put it on the road, and the lower temperatures that the asphalt emulsion itself will be subjected to. This is done it's basically a thin film is drawn down on a silicone sheet, and then that's put into a 60-degree C oven for 6 hours to give you a smaller amount of residue that's usually used for testing like the multiple stress creep recovery and original dynamic shear recovery. Some of the other tests a few of these have been mentioned on some of the previous discussions. Some of these tests are penetration. So penetration, or you may hear it called PEN, this is basically measuring the consistency of the asphalt by how hard or soft is this asphalt at a given temperature. Then there's ductility. Ductility measures the tensile properties of the residue, and this is determined by how far will a sample elongate before that sample breaks. Float test is an interesting test because it's a residue performance test, but it's also a little bit of a characterization test. There's a category of emulsions called high float emulsions, and so this float test characterizes the flow behavior of high float emulsions, typically at 60 degrees C. So if you have a high float emulsion, this will typically be part of the specification to test and ensure that it does actually meet the high float requirements. And then also absolute viscosity, and that determines the apparent viscosity of the residue itself. This next category of tests are performance tests, but all of these are used to indicate the presence of polymers. CJ talked a lot about polymers, and so agencies have specifications in place to ensure that appropriate loadings of polymer are present in the asphalt emulsion that they're purchasing to give them specific performance that they want. Typically, these tests, you'll see one or possibly two of these tests specified for anything that is a polymer modified emulsion. So these tests are elastic recovery, softening point, the torsional recovery, toughness and tenacity, multiple stress creep recovery, and also the dynamic shear rheometer. Solubility and ash, both of these tests are used to test for the presence of deleterious materials in the residue. AASHTO M140, M208, and M316 are all emulsion specifications for the anionic, cationic, and polymer modified emulsions. And all of these state that testing of the emulsified asphalt properties should be completed on the sample within 14 days of sample date. That's one of the reasons that it's important that as soon as that emulsion is sampled, that it's sent in to the lab on the day it's pulled, because the clock starts ticking on that day. And then also that the testing of the emulsified asphalt residue properties themselves should be completed within 30 days of the sample date. Thank you for giving me this opportunity to discuss this. Let me know if you have any questions. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.